So I want to walk you through setting up the AWSPics project that I was recently working on. It's a cloud formation stack for Amazon Web Services that'll run a serverless, password-protected photo gallery. So my goal here was to have something that was self-contained that I could have statically deployed a photo gallery and put all of my kind of personal pictures up there so that I can share with friends and family without having to depend on a third-party service or needing to run or maintain any servers. And so this was kind of a fun experiment because I'm not really a web developer or a DevOps person, so it was a good learning experience. So let's dive right in. You can read more in the README and in the blog posts about how this works and the different components that are involved. I'm really just going to go through the instructions here one by one so that if there's something that isn't clear from the instructions, you'll be able to watch this video and get a better sense of exactly how things work step by step. All right, so we start off by, so I'm logging in here to a fresh Ubuntu instance. There we go. And we'll go and install a few dependencies that we'll be using here. The first is Python pip, which is used for installing the AWS CLI tool that we'll be making heavy use of. There's also the Apache 2 utils, which comes with the htpassword utility, which is useful for setting up the credentials that we'll want to enable for accessing our private photo gallery. And then finally, there's Docker, and that's going to be used to build the Lambda services that we'll be using. So as that's installing, let's kind of walk through a little bit of the architecture. There's 7 main parts here. The first part is really the interface. All of this is behind an AWS CloudFront instance. They call them distributions, and this is really going to be the interface to everything that happens under the hood. And so you can think of CloudFront as a CDN, a content delivery network, but it's quite a bit more than that because it can also require that objects be signed, so restricting bucket access for the data that's being served via the CloudFront instance. And that's really what we're relying on here to protect the contents of the site to prevent any unauthenticated access to either the website itself or its pictures and assets. So that's the first part. The next component that a user would see really is the login component. So what happens if you try to access the AWS CloudFront distribution and you haven't yet authenticated, it'll return a 403 HTTP error, which will then load our custom error page, and we'll see how we actually set that up in a moment. This custom error page is actually a login page that will post the login request to the login Lambda function, which will go through this API gateway, and that'll hit the login function in Lambda. And this will check the sent credentials against the htpassword credentials that we set up or that we're about to set up as part of these instructions here. This will return CloudFront signature cookies. So these are just front-end web cookies that the browser will then store, and then any subsequent requests to this domain will submit these cookies. And because they've been signed by an Amazon role that has permission for signing this CloudFront instance, the CloudFront instance will then forward these requests to whether the web bucket, the resized images bucket, which is really what we're serving the images as, and then the source bucket for the original images, the full resolution ones. And the reason why we have these 3 buckets here is that, one, I want to preserve the original photos in full integrity. And so any image that you drop in this source bucket will be preserved there. And anytime you drop a new object here, it'll trigger this resize Lambda function, which will produce resized variants of this original image that will then serve as part of the website to really have a more optimal browsing experience. Now, anytime a new object is dropped into this resized bucket, we'll trigger another Lambda function that will build the site. And this builds the static website that will then store in this web bucket that will hold all the HTML, the CSS, the JavaScript that CloudFront will then load. So really all of this kind of goes through CloudFront. So those are all the main parts, really. So everything installed long ago here are all our prerequisites. Now we still have to pip install the AWS CLI and make that available in our path. So we'll do that. All right, now we should be able to find AWS. The next step here, and we'll actually go ahead and follow the instructions just to make sure that everything's in there. So the next step is to configure AWS. So let's go do that. And I have my very private information here that I'll destroy shortly after making this video. But you can use your own root AWS account credentials for this, or a new IAM role that you create that has access to administer all of the changes that we'll be doing here. Now this is very important. Default region. I'm setting US East 1, which is the North Virginia region. And it's important to set it to this region. Almost the entirety of this project is region agnostic, except for one very critical part, which is creating the SSL certificate via the Amazon Certificate Manager using CloudFormation. At the moment, AWS requires that be done in the US East 1 region. It's fairly easy to adapt this project to work with any region. You just have to disable that part from the CloudFormation stack. So if we look at our app.yaml here that describes the CloudFormation stack, you would really just have to comment this out or just delete it. And then where there's a reference to this in the CloudFront distribution, rather than having the reference, you'd have the Amazon resource, whatever ARN stands for the SSL cert that you've set up. Okay, but since we're doing this in US Region 1, US East 1, we don't have to comment that out. All right, so we don't need to set a default output format. Whatever is default is fine. All right, so now we've set this up, and this, I should say, by the way, is basically a new AWS account that I just created just for the purposes of this demo. The only thing that it has set up at the moment is that it does have a domain under Route 53. So we can go and see what that is now. That's AWSPics.net. And it really just has the default record sets and hosted zone that AWS sets up for us automatically when we register a domain. All right. So really, you don't need to be using AWS for hosting your domain or your DNS. You can use whatever your DNS provider is at the moment. That's perfectly fine. It's just kind of simpler for the purposes of this demo. Everything else is really from scratch with this AWS account, so that makes things really easy to make sure that I'm not missing any steps that you'll need to configure in the instructions. All right. There's another step here when configuring AWS, and that's to enable the CloudFront preview, which will allow us access to a bunch of CloudFront functionality via the AWS CLI, which is currently in preview stage, right? So you need to explicitly set that up. All right. The next step is to set up an AWS KMS key, key management service. So this is an encryption key that we'll be able to use to sign all the sensitive information that we need to set this up. So we'll go and create that key, and we'll take note of the key ID. All right, so we'll store that here. Now, please do note that KMS keys cost about $1 a month. So that is going to go towards the cost of setting this up, but you can reuse one if you already have a KMS key. And even after you set this one up, say you don't have one already, you can then use this key for other things. They're really not kind of tied to any stack or any sort of application or resource that you have on AWS, which is why I think it's not terribly easy to set this up as part of CloudFormation, which is why it's part of these upfront instructions. All right. Now, we should also create a CloudFront key pair, and this will be used to actually sign, create the signatures for our CloudFront bucket restriction. So you can do that in the CloudFront key pairs. And you can see that I've created a few already as I was developing this stack, but they're all deleted, so we're still in our kind of fresh environment. All right, so we'll go and create a new key pair, and just like that, it's created one. We'll download the private key file and the public key file and store them somewhere safe for safekeeping if we need them later. And we actually will need the private key for later steps in this. All right, so I'm just refreshing here to make sure that the key is actually active and everything worked fine. Now, after that initial dialog box disappears, you can no longer download the private key. You can only download the public key. So that's why it's very important to do that up front if you want to preserve that for safekeeping for later. All right. So our next step is to encrypt this CloudFront private key using the KMS key that we created in step 2. And again, just like the KMS key, you don't need to create a new CloudFront key pair if you already have one. You can reuse these for across all the resources that you have for your AWS account. All right, so we'll go and copy that, and we'll go and replace this placeholder key ID with the key that we took note from the step earlier. And there we go, that's our command. Now, however, if we run this in our new Ubuntu instance, we don't actually have anything here. I haven't cloned this repo, and this repo is private right now. So I've just set up this little rsync command that will copy the repo from my local machine over to this Ubuntu machine. So now we have this AWSPics. So we'll cd into that, and let's also move the primary key that we just downloaded to this directory as well. All right, so now we have it in our Ubuntu machine. So now we can actually run this command. All right, now that's a whole lot of gibberish. That is the output from the encryption. We're encrypting our private key, our CloudFront private key, with our KMS encryption key. All right, so we'll actually store that for safekeeping. So we'll call this encrypted CloudFront private key. All right. Now, in step 3, we actually had this step that said take note of the key pair ID, which we didn't really do, but thankfully that's actually the name. It's in the name of this private key, so we can just copy that out. Key pair ID. So there it is. We'll need to use that later. All right, next up, we can create the credentials that our private photo gallery will support as authentication. And you can create as many of these username, password, key pairs as you'd like. In this case, we'll just create the one with a username of username and a password of password. All right, and if we look at what that looks like, it'll generate this hash. And really, this HT password file, as long as like all the new lines have this username, password, or encrypted password key pair, or hashed password rather, that's a valid file. So you can create as many of these as you'd like. You just have to append to this HT password file. All right, the next up, we then encrypt this HT password file with our encryption key. Again, the one that we took note from earlier. So now we can run this command, and we have the encrypted HT password file. So, great. Finally, the last manual step here is to create a CloudFront origin access identity. So this will be used to, this is an identity that's used for CloudFront to access the restricted bucket contents. All right. So we'll go and, actually we don't need to replace anything in this command. Let's break this down a little bit. So this creates a CloudFront origin access identity, and we explain what that is. And then you need to pass in a config, and the config is a unique color reference, which I'm just doing this kind of gymnastics to kind of generate a 14 long key that we can use that's just random to make sure that we're not using something that already existed. And we're putting a comment that's useful here, like AWSPics OAI, which stands for this origin access identity. So we'll run that. And so this created our access identity. And we need to keep note of its ID as well. All right. So by the end of all of this, you should have the KMS key ID, the CloudFront key pair ID, the encrypted CloudFront private key string, the encrypted HT password string, and the CloudFront OAI ID. And it's with these settings that we'll populate this config.json that we can use to deploy our application. All right, so you need to create a file in the dist folder called config.json. There's an example one here in this repo. So what we'll do is we'll go and copy that into, first let's make this directory. There's nothing in there. And we'll copy the config file into place. And then we'll go and populate our settings here. So there are comments in the README that explain what all these values are here. So hopefully that's fairly easy to understand. Now, the website is actually the domain where we're hosting this. So in this case, AWSPics.net. You can specify a title that will be in the HTML. In this case, let's call this what it is. Maybe just CloudFormation stack to run a serverless password-protected photo gallery. A web bucket. Now, this is the bucket, the S3 bucket, where the HTML files will be stored. And unlike exposing an S3 bucket directly to the internet using the website hosting property that you can do via Amazon S3, this doesn't need to match the domain that it's going to be hosting because it's going through CloudFront, and CloudFront takes care of redirecting the request to the appropriate bucket. But in this case, just to keep things simple, I'll still name it the exact same. So that's the web content. Now our source bucket, by the way, the web bucket is where we'll be storing the generated static website. And that's the default origin for the CloudFront distribution, which means that any request that hits the distribution, that hits that URL, that doesn't match any other cache behavior pattern. So this is a bunch of AWS lingo to basically mean that any request that doesn't hit any of our URL path regular expressions that will then determine which origin to use. So for example, AWSPics.net/pics/resized/ etc. Is the URL scheme that we're using for our resized images. That will redirect to the resized S3 bucket. Same thing goes for the original, and then anything else will go through the web bucket. So that's that. So now we're setting up the source bucket, and again, this doesn't necessarily need to be anything related to our domain, but I do find it easier to do that. So I'm just going to append -source to the domain and do the same thing with resized. All right, next up, we have the origin access identity, and we took note of that. And it's this ID here. Session duration, that's how long the signed cookies should be valid for until the user is automatically logged out, and then they'll be prompted with the login page again, or the error page. All right, now this KMS key ID, we also took note of that very early on. So it's this value here. And I just screwed something up here. There we go. All right. Next up, we have the CloudFront key pair ID, which we took note of. Then we have the encrypted CloudFront private key. That's the first thing that we encrypted. And then finally, the encrypted HT password file. All right. There we go. We have our config file. And it's very important to not check this into source control if you're forking this repo and setting this up yourself, because there's some sensitive information here. It's not, I don't think there's actually anything that's too sensitive, because everything that's in here is encrypted and we're not storing any of the private keys, but I would still play it safe rather than be sorry. All right. So there we go. Now our next step is just deploying everything. So that's the best part. We can go and deploy our stack. And as that deploys, I can walk through a few more things about how this works. So the deploy script takes the name of an S3 bucket where the Lambda Docker images, the Lambda code, will be stored, because that needs to be uploaded to some S3 bucket. You don't need to specify a bucket that already exists. You can create one that doesn't. In this case, we actually don't have any buckets that exist, or shouldn't anyway. Yeah, so this doesn't return anything. It'll create it on demand, or it'll just reuse it if it already exists. So if we look at the deploy script and what that looks like, first, it creates the Docker images for all of the Lambda functions that we'll be using. And we have 3 Lambda functions. We have a login one, a resize one, and a site builder one. And all of these, the code is available. They're actually fairly simple in the repo. So the login one takes requests. We'll ask CloudFront for providing signed cookies and will return them to the sender. The resize one takes images that are dropped in the source bucket and resizes them, placing them in the resized bucket. And all of this is pulling the configuration options from our config file. And then the site builder is a very minimal static site generator. It's just this single file JavaScript. And then it takes these very basic HTML templates that I've grabbed from HTML5Up, these amazing Creative Commons templates to create a really good looking static photo gallery. So that's the first thing that the deploy script does, is it will go and generate all these Docker images. So at this point, we're still building the Docker images. The first time that this builds is going to take a little while, but the Docker layers will then be cached afterwards, and so will all the intermediate steps as part of the Docker file. So for example, if your package JSON doesn't change, you're just making changes to index.js, it won't have to re-npm install. It won't have to recopy these things here. So subsequent deploys are much faster. So we build these containers one by one. In this case, since we're starting from a fresh AWS account, the AWSPics Lambda bucket that we provided as our deploy argument doesn't exist, right? So we get this error, but that's all right because the deploy script actually just checks to see if it exists, and if it doesn't, it'll go and make the bucket, mb bucket. So the bucket's made, the AWS, or rather the Lambda Docker images have been uploaded. We've now packaged this CloudFormation stack or package, and now we're in the process of deploying it. And we'll see this waiting for stack create update to complete step for actually quite some time. We can go and monitor this progress in CloudFormation in the AWS console, and we see that this stack is create in progress, and it's using our AWSPics name. So this will actually take a while the first time that you run it. So this started at 12:09. I suspect that this will take anywhere from 20 to 30 minutes. And there's actually one interactive element to this. If we look at SSL cert, this is requesting a new certificate from AWS's certificate manager. And there's an interactive step here where AWS will request the registrar send an email to whatever the whois info that registered the account is for this domain. And here we see that we actually just got this email. So here we have, we actually got a few of them just because I have a catch-all from my email. So it sends one at tech, one at owner, and one at admin. So you can click on absolutely any of these to approve the request, and this will complete the SSL certificate creation. Right, so we don't need to access my email anymore. So again, now it's just a bunch of waiting. This screen sometimes automatically refreshes, sometimes it doesn't. But we can see that it's creating all of the components that we need to run the stack. So first it creates the stack itself. And then the order in which it does this is kind of determined by the shape of your AWS stack manifest or YAML. So we can start walking through this here. So this is the one file that determines the kind of declarative infrastructure that this whole stack is going to be using. So we first have all of the parameters, and these are really the same values that we had in our config.json that we set up earlier in the dist directory. So that you can actually see these in the parameters aspect of the stack, which is, I don't know, kind of useful to get a kind of bird's eye view of what all of the different components are. And the rest here is really just kind of declaratively describing what all the components in the stack look like, how they're configured, what they're named, where they're getting their values from, how they deploy, and how they interact together. And so we can start going through these one by one, since we have a while to wait for this stack to deploy. And if we refresh, we should see some more things. In a minute, you'll probably see that the SSL cert was successfully created too, which you don't see right now. There it is. Create complete SSL cert. This is already almost completed. It went from 12:09 to 12:13, so it really just took 4 minutes for a whole bunch of complex components to all be set up, and the remainder of this time is really going to be spent creating the CloudFront web distribution. For some lovely reason that has to do with CDN propagation, probably. CDNs take a really long time to update, probably because they're updating regions all around the world. But that's probably going to take the remaining 20 to 25 minutes of this setup. So while that's going, we can take a look at all the pieces that are involved here. So we mentioned there's a login Lambda function. Maybe we can refer to our fancy diagram here. Architecture diagram. How about we just open it? Here. All right. So the Lambda login function. So what does that look like? It's a serverless function, which basically just means it's this, what do they call it? A translation layer that will create multiple subcomponents of CloudFormation types. So a serverless function means that it not only creates a Lambda function, but it also creates an API gateway API that will redirect its endpoints to this function. So it's kind of handy because it's a nice way to expose a function via an API. So a few metadata aspects, like this is using Node.js. It should redirect any request to this index.handler, which if we look at that, we're exporting the handler here, so it really just means that it's going to run this closure upon request. The code URI here, that is pointing to the Lambda login Docker output that we created as part of our deploy step. So this is actually pointing to the zip file on the S3 bucket that we provided to our deploy script. Now you specify this role, and the role describes what permissions and what context that this Lambda function is running under. And we're actually referencing this role from the role that we're defining here. And you'll actually see a lot of these interdependent references between different resources that we have in our CloudFormation stack manifest here. So here this just means that we might not have the role just yet, but when you end up having it, the Lambda function should assume this role that you may or may not have created yet. So that's what that means. And we're passing in a few of the configuration options that we configured in our config.json as environment variables to the login function. So this will grab what website it's generating the cookies for, the session duration, how it's signing these cookies, and what passwords it's allowed to pass through, what passwords are valid. So that's the login function. Now this Lambda role is not too much that's interesting in this top part. This is pretty standard for an AWS Lambda basic execution role. It just means that this role can be used to invoke Lambda functions. The interesting part here is the policies. And this policy gives the role, and therefore the Lambda, access to decrypt things via the KMS. So specifically, we're only allowing this role to access the key ID that we explicitly passed in here in our config.json. So we can only use this role to decrypt, and only do so with the key that we're passing in. And this is kind of a general theme that I found is a best practice when doing things with AWS, is that it's very easy to just say, well, everyone has access to everything and open resources up to the world. But that's very dangerous, because that opens yourself up to third parties finding out that you've exposed, say, an S3 bucket for just public read-write access, and then they can hijack your AWS account and drive it to the ground, cause like all sorts of exorbitant fees, and run like botnets on it and stuff like that. So very important to take that extra effort to make sure that you silo all of your policies, all of your resources, so that you're only ever exposing just the amount of access that is necessary. Now I'm going to go a little faster for the rest of this part here. The resize function is very similar to the login serverless function. It basically describes or references what roles it has access to. It needs way fewer configuration options, just what bucket to put the resized images in. But we are increasing the timeout and increasing the memory size that this Lambda is allowed to use. Timeouts in seconds and memory sizes in megs. And so we're allowing up to 30 seconds of image processing time and up to a gig of memory use. And I'm just being overly generous here to make sure that even large images are resized without problem. So here the role for this Lambda function is a little, well, it has a few more things. Really just two policies: the ability to get objects from the source bucket, and the ability to put objects to the resized bucket. And you'll notice a lot of these references and substitutions too. So the CloudFormation Lambda, the CloudFormation manifest domain-specific language, if you will, has a few functions that you can use. And this is useful when you need to compose kind of a larger string using that's derived from a value that we already have. So in this case, we need an ARN for the source bucket, and then we also need to say that you're allowed to get anything inside that bucket, not just the root object. So that's why we have this. So that's what's happening here. The site builder, again, very similar to the other Lambda serverless functions. But again, we have a bit more memory. And here, so a few configurations. Here the role is the most complex role that we have for this Lambda, where you can get objects from the source bucket, because that's how the serverless or the static site builder will determine what to build, because it'll go in and get objects from the source bucket, but also list all the objects from the source bucket. Um, and this is how this whole stack is data driven or object driven, where all you need to do to kind of configure which galleries you have in this photo gallery is to drop pictures in folders. And so by listing the sort of directory structure, even though they're not directories, they're just S3 objects, by listing that structure, the site builder can determine how to set up the website, what albums it has, how many pictures it has, etc. So we can get the contents of objects, and we can also list the entire contents of the bucket. So that's very useful. And this is only for the source bucket, mind you. We don't need to access the resized bucket, because the site builder will just assume that the resized images are that they exist and that they're at the expected place. And since we control the whole stack here, we can make that assumption. Now there's also, we need the ability to deploy or push the statically built site to the web bucket. So we have this put object permission or policy, excuse me. And then finally, this isn't strictly necessary, but I've found it very useful. The site builder function will actually go in and validate the CloudFront distribution. And this is extremely useful because it means that anytime you drop a new image in the source bucket, it'll go and resize it, it'll go and generate the site, and it'll all automatically inform CloudFront that changes have been made to the site, so that it knows to invalidate its cache, so that the next time that you refresh in your browser, you'll actually see the changes that you made. So let's take a break from going through this. We're more than halfway done, and we'll take a look at how our deployment is going. So refresh this. We see that we're still creating this CloudFront distribution, and it's just been about 10 minutes, so it's still churning through. All right. So now we can start looking at, let's just collapse these. All right. So we have all these resources to go through again. This resize, all right, so let's see what this is. So these three resources have to do with the source bucket. And the way you trigger Lambda functions from bucket events is that you set up these Lambda permissions, and then you set up notifications to be sent out on the bucket policy. So what does this look like? All of this permission is really just saying, well, this is the permission that I'll use to trigger the resize Lambda, and it's going to be notified from the source bucket, but we haven't specified that notification yet. We're just setting up this kind of intermediate object. Now, we also need to create and manage this S3 bucket for the source bucket as part of this CloudFormation stack. And this is what's responsible for making any changes to the bucket configuration, creating it in the first place, tearing it down if we end up deleting this CloudFormation stack. So that's in there. And it has the name of the bucket, And it depends on this resize invoke permission, which again we haven't set up, but we are setting up this notification configuration. And this is where the dependency cycle, or the dependency management between between resources in this CloudFormation manifest is super tricky and really important to get right. So here what we're saying is that when a new object is created in this source bucket, invoke the function resize function. All right, so now we've set up this notification. That means that anytime we drop a new object in this source bucket, it'll trigger the resize lambda, which is what we want. Now, we also here set up the other side of the CloudFront distribution's access to be able to access the restricted buckets from our CloudFront distribution. We need to tie it back here and to say that our origin access ID that we created much earlier on in the process has access to get the objects from this bucket. Right. So this provides the ability to access the bucket contents of the source bucket only via CloudFront. Right? There are no other policies on this bucket. There is no one else other than the Lambda functions that we described earlier and this CloudFront origin access identity. No one else can access the objects in this bucket, which means that you need to go through the CloudFront distribution in order to be able to view the site and to view its pictures, right? So that no one can kind of bypass that. No one can access your pictures that you've set up as part of this private photo gallery, right? Which is the whole point of this exercise, is to have this private photo gallery. And we have very similar things that happen with the site builder, right? Where we have the ability to invoke the site builder function when new objects are added to the resize bucket. We configure what the resize bucket looks like based off of the name that we passed into the config.json, and we trigger the site builder function when a new object is created. And then finally, we tie together this origin access identity to also allow the CloudFront distribution to serve objects that are in this resized bucket. Web bucket, very similar, except it's a little simpler because we're not triggering any sort of Lambda function when new objects are created in this. We don't need the notifications component, and therefore we also don't need an invoke permission that's tied to this bucket. Right, so that's where we're storing the HTML and CSS and JavaScript of our static website. But we still need to allow get access to the objects in this bucket to the origin access identity. All right. Now it's possible that our distribution is finished, and it's not quite. It's been about 17 minutes, and now you see how 4 minutes to create every resource in this stack, and then so far we're 17 minutes and counting to create the distribution, and it's still going. So it's by far the lengthiest component to deploying the stack. All right, now we have this SSL cert, and we saw that this was created almost immediately when we started this, right? So if we go back in time, you see that we're kind of creating a stack, creating a few roles, and creating this SSL cert. And that really just kind of reflects how the dependency resolution works for CloudFormation, where it'll really just generate the resources that don't depend on other resources first, obviously, right? So it needs to create the resources that aren't dependent on anything else first in order to kind of move on with everything else that it needs to configure. And in this case, all of this does really is saying that we want an SSL certificate with the domain name that we're passing into this config.json. Right, and in this case, this is what prompted the email to be sent, requesting permission to actually create an SSL cert for our AWSPics.net domain. All right, now there's a single final resource that we have to go over, and it's a little complex because it has a few other things. So we have our CloudFront distribution. So let's break this down. There are aliases, and the aliases are the CNAMEs that CloudFront will allow you to access its web content. And in this case, we're only allowing AWSPics.net to access this distribution, so that once we've set that CNAME up in our DNS settings, we'll be able to view the contents of this distribution from that domain. Then we have origins, and origins are the sources of content that CloudFront can redirect requests to. So we want to serve, if we go back to our architecture diagram here, we want our CloudFront interface to be able to serve images from the source bucket, and we'll get that when the user requests to download the original image. We want the interface to be able to serve the resized image, which we'll be displaying in the actual website as part of the viewing experience. And we have small thumbnails and large but not original size images when you're viewing things full screen. There are really two resized assets for each original image that we're storing in this. And then we also want the CloudFront instance to be able to serve the web bucket. So here we have these origins where we're allowing access to the resize bucket via this origin. We're allowing access to the source bucket, and we're allowing access to the web bucket. So that's accessing this component here, but we still need to hit the Lambda function and to allow that from within an HTML page, we need to make sure that we're on the same domain, because otherwise we need to deal with cross-origin request scripting cores, and that's just a hassle that I don't want to have to go through, especially because I know very little about front-end web. So just by passing everything through this CloudFront, it's also nicer because it means that rather than hitting some randomized domain that the API gateway is setting up for us, we're going through our domain that I don't know, just feels a little nicer. And so that's this final origin here. And we require that you can only hit this via HTTPS. So this again references the serverless REST API that we set up as part of our login function. So again, that's part of that declarative infrastructure that we've been talking about. Now, these origins, just setting those up isn't enough to actually serve content from a CloudFront distribution. You also need to tell CloudFront which requests should be routed to which origin. And so this is where we set up the path patterns that I was mentioning earlier, where anything that hits pics/resize/something else is going to be redirected to our resized bucket. And we require, we have this trusted signers here, which means that access to this bucket's contents is restricted. So it requires either signed cookies or signed URL parameters, like query strings. And in this case, we're saying that only our AWS account should be allowed to go and we're saying that only our AWS account should be allowed to sign these requests. So we do this for pics resized, we do this for pics original, and then we also need to expose the API for logging in. And in this case, anything that hits awspics.net/prod, which is the stage name of our API, will be redirected to our login API. Right, so that's basically what that looks like. Now, there's a default root object, which means that when you access AWSPics.net without saying /index.html, it'll leverage this root object, which is what we want. We have some custom error responses so that when you're first hitting this domain and you don't actually have signed cookies, we will redirect you to the error page that we've deployed as part of our static site builder. And this has the login form that we'll use to then hit the login endpoint for the API distribution. And when that returns, you'll get your signed cookies so that you can access the rest of the photo gallery. And we're also redirecting 404s to index.html so that you can always find your way back to a photo album, even if you typed in a URL incorrectly or something like that. Finally, our default cache behavior just means that for anything that doesn't match any of the path patterns that are defined in cache behaviors, route everything else to the web bucket, which means that we'll basically use every other path pattern as a request for our static site. What else? Finally, we have the SSL cert hookup, which tells the CloudFront distribution to serve any HTTPS traffic using the SSL cert that we set up here. All right, I think that's the entirety of it. And here we can see that our stack is finally deployed. So we finally had this deploy, and then the last part of the deploy script was to invoke the site builder function, which will generate the first version of our gallery. So now, if we refresh this, we'll see that our stack has been completely created. Hooray! However, if we visit AWSPics.net at the moment, you won't find anything because we haven't set up a DNS entry for it. And this is where you'd go to your domain's DNS settings. In this case, we're doing this through AWS, but it doesn't have to be. It can be whatever you're using as your DNS provider. We'll go and create this record set. Oh, and actually, I forgot that there's an aspect that you need to do first. The value that you need to provide for the CNAME here is the CloudFront domain that was set up. So it's this domain name here. It's kind of tricky to highlight, but if you click into it, you'll see it here. All right, so we'll go and copy that. Oh, and by the way, if you go and access this, you should see our error page. And this is the error page that's actually set up as part of the site builder. And we're only seeing this because we specified our custom error response to return the error page for 403, which is the case here. If we look at our console, we're seeing that requesting this returned 403 forbidden because we don't have the signed cookies. Right, so now that we have that domain, we can go and specify it as a CNAME. Now, because we're dealing with the root here, and it's the first time that I actually follow these steps with the root domain, and you can't specify um, you can't specify a CNAME. Maybe we'll just go and specify this this alias as an A record, and maybe that'll work. But regardless, something else that we want to do, and again, since this is the first time that I'm doing this with the root domain, I haven't had to do this yet because I've just been testing this out on like v1.awspics.net, v2.awspics.net, etc. We'll go and do a substitution and do some live coding here, and also specify the triple W just in case the root domain doesn't work, and then we can also see what a redeploy looks like. All right. So hopefully this works. I mean, now that we've set up this this A record, this might actually work. I'm not totally sure, but we can try. We also need to wait a little bit for the DNS settings to propagate, because right now they're not being found. So we can wait a bit, and in the meantime, we'll go and create the triple W version of this, and yeah, so we were using this domain name. Right, so that at least one of these should work, I'm hoping. All right, so now we've added this alias. Okay. We'll go and make sure that we have the latest here. And we'll do another deploy. And this is where hopefully the deploy should be much faster. Here you see that we've already just reused the same caches for our Docker images that we set up for our Lambda functions. And now we're redeploying our change. And we'll just keep trying this out as that goes. Now we have an update in progress. And it should be updating the CloudFront distribution because we're adding a new alias. And if you go to CloudFront here, you'll see that it's in progress. And now we see we have multiple CNAMEs. So that's great. Let's go and yeah, so that's still not resolving. Maybe Safari can help us. Nope, it's still not propagated. That's all right. Now, even after the initial deploy, subsequent changes to the CloudFront distribution can still take quite a few minutes. You kind of have to be patient. Now, because I requested a certificate from AWSPics.net, this means that www.awspix.net isn't configured. So we'll go and use that anyway. And we're still not getting the DNS address here. All right, well, let's try this. Username, password. And this may not work because the SSL certificate isn't valid. And that appears to be the case. I wonder if we disable the cache. It's already disabled. It seems like we're actually getting some IP addresses for AWS, and there we go. Okay. So we'll deal with the triple W issue later, but now that this is fully deployed, we can go and log in. So let's first try with the wrong password. Incorrect username or password. Now if we try username and password, which is what we set up earlier, loading site. Right? And we see we have the title that we used in our config.json, but we have a completely empty page here. And now we're actually logged in. And if you see, if we go and access this in Safari, you'll see that because we don't have the cookies in this browser, we're still getting that error page. And if we went and removed the cookies from Chrome and load this again, we'll still get the error page. The wrong password returns incorrect username or password. And the correct credentials work. But this is an empty page, not terribly exciting. So and here we're still waiting for the template to update. But since this is mostly working, let's go and we'll just wait for this to complete. So let's take a look at another script that I have in here, which is generate random albums. So the way you use this is you run it and then you specify how many random albums you'd like to use. And what that'll do is it'll go and clean up all of the buckets that you've specified in config.json, so the web, source, and resized buckets. And it'll go and delete all of its contents, really have a clean slate here. It'll pull 6 random pictures from unsplash.com, great source of high resolution, high quality photos. And so it'll pick 6 random pictures for each album that you're generating, give each album a random name, and then upload everything up to the source bucket. Um, and really, that's putting a new image in the source bucket is the only thing you have to do to update the site. So, for example, if you use a popular S3 browser like Panic's Transmit app, you can use that basically as a file browser and drop images to your new photo gallery directly in there, and that'll automatically add them to the site. So let's go and use this. Let's just create a single album for now, because that's going to be the fastest. So we're downloading these images from unsplash.com, downloading them locally, and we'll just pick 6. And now, every time we're downloading one, we're also uploading it to the bucket. So if we want to use things like, well, first let's see all the buckets that our stack has created. So there are our buckets. And if we go and want to list, say, the contents of our source bucket, we'll see there's a pics directory. The pics directory has an original directory. We have a single album here. So we can go and list that. And we see that we have 5 pictures, right? And then they were just uploaded just now. And so that completed. If we go and take a look at our Lambda function, we'll see that we can go and see some logs for this. Right? So if we go to monitoring, view logs in CloudWatch, you can see all of the different login attempts that I made, right? So here we had a few unsuccessful logins, a successful login, etc. If we look at the resize function, we'll see that it was invoked for every image that we dropped in there. So we had 1, 2, 3, 4, 5, 6 events because we dropped 6 images, and we resized all of those images. And then finally, if we look at that's the login function. If we look at the site builder function, we can also view its logs. And we can see that we have been generating the site here. We can see how much memory it used, how long it took. So very useful logging. Now all of that was kind of a distraction, but now we should see our one album that we created. And if we go and click on that, we'll see all of its pictures. Now, this is serving from the web bucket, but if we look at open image in new tab, we'll see that this image is actually in the pics resized URL, which is serving directly from the resized bucket. And so this is the small thumbnail that it's generated, and then there's also this large one here. And if we go and take a look at its contents, that's in the pics resize, but it has a different value. Right. So that's the another resized version. And then if we wanted to go and download the high resolution version, here we have the high res version. In this case, this isn't terribly large. This one's probably larger. Now the images that are from unsplash.com aren't all right? So are all massive. So in this case, all of these images are actually smaller than what I resize them to. But this is very useful if, say, you're uploading the raw JPEGs straight off your camera, um, no resizing, just like 20 megapixel, whatever it is. You can still get to the original picture, but you're not going to slow down the viewing experience when looking at this when looking at this photo gallery. So in practice, you'd probably want to not use the generate random. Generate random albums. You'd probably want to post your own personal pictures for sharing with your friends and family. But that, in a nutshell, is how this all works. I know this was a really long walkthrough, but there are surprisingly many components to having a serverless, password-protected photo gallery. So thanks for watching, and hopefully this is useful for building your own AWS stacks.